My name is Denis Angell. Thank you for coming to this talk about the Hooks library. The Hooks library is an actual library of hooks that I've audited or that Richard's created or that community members will create. The Hooks toolkit is an SDK for interacting with hooks, because interacting with hooks is quite difficult at this time. May not be difficult for some of you, but for the new people, it will be difficult. For those of you who don't know me, I graduated with a degree in securities finance. I graduated with an insurance license and a real estate license. I studied for my Series 7, and I worked for an RIA for almost a decade. In 2014, I discovered the EVM, and I started writing smart contracts. Shortly after that, 2 years later, I built an application that on a mobile phone that could do Ethereum, XLM, and XRP. And at that moment, I never really looked back at EVM again. And I sort of took on the assumption that smart contracts would never be a thing, and I'd have to just work around it by using XRP or the XRP ledger, because the ledger was just superior, in my opinion. And then I discovered Richard's amendment, and I sort of became obsessed again with smart contracts. I have a number of Solidity contracts already written. I've ported almost every single one of them over, and I would argue that there is nothing we can't do that you can do in Solidity. We do it differently, and it may take time for somebody who doesn't understand it like me, but I would encourage anyone to reach out. If you think we can't do something in hooks, reach out to me, and I will accomplish it. So the Hooks library, thank you. So to get started, you would need to install some global things. The first one is C2WASM, which is another tool I built, which builds hook contracts. The second one is what I call XRPLD, which XRPLD CLI, which you can create a standalone environment, or you can also create a mini cluster, which there's a difference between standalone environments and sort of a cluster that's running on your computer. If you've ever worked with EVM, it's like Ganache, where the transactions clear almost immediately in the standalone. That's what I develop in. You will never see me interacting with the testnet or the production network if I am not in a sandbox or production environment with one of my applications. So I always spin up a standalone environment. There is a demo project that I have that anyone can it's public, and on the master branch, it pretty much sets you up with that entire get started. So environment, contracts, and then an example there, but we can just scroll down through it. You need to add your environment variable, and you need to point it to the build box. Here is where you would designate whether you're using standalone or a mini cluster or production. And at that point, I'm going to go ahead and spin up the standalone. So the standalone comes with a couple things here. Two things. One, that's your standalone, and then the other one is an Explorer. This is a sort of my custom build of the, it takes a second, but of the XRPL Labs Explorer. So while that's building, let's just go back over here. You'll notice it added a directory here, and this includes your Ripple configuration, your validator list, and then your debug log. So you can already see it's in there. And so the second thing I would always do, and I think if we go back here, it should be next. So up standalone there, and then it is not listed on here. It's listed over here maybe. Yes, here, tracing the output from the hooks. We want to do that because reading this debug log is a lot, and if you don't know what you're doing, then you can get lost. So I always do that. And then let's go back over and hopefully the ledger's up. So this is what the standalone looks like. It's not going to close ledgers until I do. And so that's why it will always say connecting, so it might be a little confusing. So then we're just going to jump back in and do some building, which is the C to WASM. So when you build C to WASM, what I did is you can see the contracts directory. Inside of that, when you run this, either this function or at the core is C to WASM contracts build. It will build everything in that directory, even if things are nested inside of it. You can see base C, that's my base hook. If I had a folder directory, it would still build everything into a base layer like this. All these are old contracts. When you get errors, it will create a log for you and save it. If you've seen some of my videos, I do have an AI extension that I'll be adding to that. So if you add that flag onto the CLI, it'll take a second and then it'll try to help you out. But we're not going to look at that. So if we build it, you can see it built it. Actually, a better way would probably be to do this. So build, and then it builds your WASM file, and this is what you compile and put into your hook. We could just go through this. So when we spin this environment up, this toolkit up, it will it's going to add 5 accounts: Alice, Bob, Carol, Dave, and Elsa. It also has a gateway, and then with that, it will also create a trust line for each of those accounts, and then it will send them an issued currency. On the gateway, it will add the account set transaction so that you can transact with it default rippled. It also sets an offer. And so what we do when we run this is it just starts doing all that. And that is it funding everything and going through that process. And then finally, we'll see the set hook transaction and then the invoke transaction. And that is pretty much what was happening here. We can see the set hook here. This is the hook payload. I'll go back to the documentation. We got plenty of time. And show you each one of these in there. So first we create the hook payload. You can see that the base matches my file name. You don't need this hook toolkit. You can do all of this with JS. I just sort of obscure some of it so it's not so confusing. This is the namespace, and then we have an override flag, and then this is the transaction that I wanted to hook on. You can see it's an array, so I could do multiple. And then we come down here and we got Alice and Bob, and then Bob invokes it on Alice, which is who the hook was set on. This submit function is one that we created. Basically, again, it's so that you can switch environments just by changing your env down here. And then another thing it does is in hooks, fees are calculated differently. So you actually have to compile the transaction, encode it, and then send that blob to the fee endpoint, and it will return the current fee by calculating how expensive that hook would actually be. Then the other thing is executions, and that returns a list of executions and a return string. And then we can see down here is that little console log base finished. And then up here, we can see that is the accepted return. So everything worked out that well with that. It's a hook that doesn't do anything. It's not a great example, but it's going to get us started. So got plenty of time here. I'm going to run through this a little more. We just went over building contracts. We already did the standalone. Another thing is if you don't want to build the entire contract directory, you can just slash it and then type in which hook you want to build. This is more advanced. This is binary models. Omar was the one who created this in his app, and if you go and see his TED Talk or whatever, you'll see that he uses these. One thing that I did add to it that we sort of need are these 3 things here. So when you're interacting with hooks and you send in a currency, you can't send in USD. You have to send in the hex representation of USD. And it's a lot of people, when they do this, they'll just hex it, and then the hex will be at the beginning, and then they pad the rest of it. In hooks, we actually need the exact hex padded on both sides, which is very confusing. So I went ahead and did that for everyone. XRP address, you can see this is actually converted into base 58 format, which is required to be in hooks. That's how you read the account in hooks. And then finally, the biggest and probably most confusing one is floating point numbers. So I automatically take some of that into account. And in a second, I'll show you an example of just the ability to just create a binary model and put in a digit of 1, and it automatically hexes everything. We're going to go over, these are some of the things I briefly went over, the hook payload. So this is the file name in the build, the namespace, the hook on transactions. It gets a lot more confusing when you want parameters. So this is how you would set up your parameters. You have a parameter name and a value, and this is what I sort of talked about with XFL. And then when you do that, you want to set it to true, and this is saying that this is in hex format. If you don't do that and you send it in, then it'll automatically hex it for you, but that gets a little confusing. We have a set hook, which I talked about, automatically checks the fee and adds the fee, or that's submit transaction. Set hook just sets the hook. We have hook execution utilities. So you can get your hook executions from metadata. This is what you saw me do. You can also get it from the transaction hash, which will then get the metadata and return it. And then we also have emitted transactions, which is something we'll see here in a second when I do a more advanced hook. And then state utilities are a new thing that we have to learn about. We have both retrieving the hook state, which takes some parameters. We have a hook definition if you need to interact with the hook itself or get some data back. A lot of it, you may need the hook hash to do some things. And then this is the state directory, which will include all of the states. So this one focuses exactly on the state key, and then this one just will return all of them. So now we're going to go and we're going to see a more advanced hook. This is probably the most advanced thing I've ever written. It is a mutual fund. It is an investment product. There are 3 steps to it. The first one is a third-party money manager. This uses the same exact functionality that the governance structure uses in Zahao. It has a table of 20, and it uses a quorum of 51%. The transactions we can interact with, we can create offers and we can cancel offers. We can create sell offers, we can cancel sell offers, and then we can buy URI tokens. We have an investment limit. This is something, again, from my securities background, I know these things. We have to have an investment limit. We also have to have a trading limit. And then you'll see there a model. Everything you do in finance and securities has to have a model attached to it. So in this case, it's low risk, low reward. This mutual fund is actually going to be what's called an index fund, and it'll index stable coins. And so, again, this is a financial product, and there is a disclaimer here. If you wanted to do something like this, you would have to file what's called an N1 for a fund, and then you would need to include a prospectus. And then some of these things we'll see in the new funding offer are required in that. The second hook is NAV, which stands for net asset value. It's the current assets minus the liabilities divided by the outstanding shares. And so what this does is this sets the NAV onto the value. Or I can explain it now because we're there. But this is the new funding opportunity. This is the big one. You'll notice right away that on the account are authorized trust lines. You're not actually allowed to trade a mutual fund to anyone else. So everything has to go into the hook and out of the hook. We have a trading window, which is 16 hours. And I know everyone's like, well, decentralization allows us to trade at any time. But these investment products have to follow these rules. And I would suggest not trying to change as many rules as you can. and just following their guidelines. Same thing with price determination. It's determined every 24 hours. That's based, well, what we're going to use is an Evernote contract, and it'll be based off the number of ledgers in 24 hours. We can see the risk profile again, the number of minimum investors, the max investment, a redemption fee. That's a classic thing that we have to include, the redemption period. A closed opportunity means that once the redemption period ends or once the offering period ends, you cannot buy that anymore. An open NFO would mean that you can continue to purchase that. So now we're gonna go in and we're actually gonna interact with this. So let's go down here. I'm not gonna show you that example because now we are getting close on time. So the first thing we're gonna do is we're gonna set the hook. There's 3 different hooks. The first one, and it matters which position they're in as well. So the first one is the third-party money manager, and this is just the hook parameters to get it set up. You'll notice that each one of these is going to include a different hook, but they all use the same namespace. And so here's where you put in your parameters. The second one is NAV, and then the third one is that new funding opportunity. So let's just go ahead and run that. And so done. That's good. I'm not going to look at the Explorer because we don't need to. It's not getting cool yet. So the second thing we have to do is set the initial NAV, and we're just going to set that to 1. We can go up and review that. So that's here. So you can see I enter in that float XFL. I'm just setting it to 1. That's automatically converting to a hex and then going inside of the contract and reading it. You can see here we're starting to show some state information. So this is what the state would look like. That's what that hex looks like. You really want to, it's important in this because you have so little space that you use the number or the binary that it's required instead of sort of inside of the hook trying to do calculations. It's better to tell it and send it exactly what it needs. So we're going to keep going. We're going to buy the NFO, and this one we can look at the ledger for. So this last one, right. So this is our payment into the hook for 100 USD. And then it was a 1-to-1. So now this user has NAV tokens. So they can hold on to those. They're not allowed to sell them. They can only sell it back to the hook. So we're going to continue. Now we're going to set up the third-party money manager. This just sets the, you can have up to 20 seats. We're just going to add 1 seat right now, but this is going to set up that contract. We're not going to look at, well, we can see some hook state here, but we're not going to look at the Explorer. We're just going to go to the end. So now we're going to buy a URI token. Up in this function here, we can go over a little bit. We mint the token, and then we create a sell offer so that the hook can interact with it. But I think one of the more complicated areas here is this is a binary model that I explained earlier. So this is an XFL, this is an XFL, that's a currency, and then the address, and then the URI token just is a regular hash. But these numbers are converted on the fly, and same thing with the currency. So now if we run this, and we go over here, we've got another couple, and then we can see the URI token was purchased, and this is our account. And so this is the hook account, and that hook account does now own this URI token. And then finally, I can show you the NAV calculation, and that is in an Evernote smart contract. So it's first we have to calculate the asset list, and then we calculate the total assets, the total liabilities. This is actually something that I really like. How do you have liabilities in the XRPL? Well, if we've created everything to use payment channels, it would be possible that at any point in time, we could get our current liabilities. And that's how I would recommend structuring something like this. And I'm not going to calculate this because this is really based on offers in the hook, and I got through that, and now I'm doing the URI token stuff. So I don't really know how we're going to value a URI token. We could do it off of the last, the last value that it was sold at. But that is probably the most advanced hook I've ever had or created. That is almost done. I know I have 5 minutes, but I'm going to show you something else. This is a tool I made called Jarvis. This is artificial intelligence. You'll notice it looks just like OpenAI, the playground. What we have here is a bunch of indexes. You can index anything. You can see I've indexed the Ripple database. I've indexed documentation, JavaScript, Python, hooks, Xamarin, all of this. Then we have index models, and that's a collection of them. Right now, index models aren't working really well because the technology just isn't there, so you see a lot of them are just singled out. But here's an example of the Zao white paper, and we can go, when does burn to mint end? And that should return a response of 30 million ledgers, hopefully. We'll see 30 millionth ledger. So if you're confused, you can come here and you can ask it questions about sort of what is in that white paper. And then you can get more advanced. I don't have enough time. I'm running low. But one of the things you can see, I was able to use this JS library and ask it to create a multi-sign function, and it went through and did the entire thing. It's free to use. You do have to have XUM right now. It will in the future use tokens and payment channels, but right now there's no terms of service, so I can't really charge anybody. But I would recommend everyone come here and try to use these tools, because if you go to OpenAI or you try to use the playground, it will not have the context of XRPL. And then one more thing I want to say, because I was talking to somebody about this. This is the homepage if you visit the playground. But I would be willing to bet that a lot of you in here do not know what temperature means. Temperature, if you want correct answers, needs to always be set at 0. If a temperature is 1, it's going to give you guesses on information. So this is it's sort of misleading here. And you can see that I will always, on my GPT-4, have it set to 0 and a couple extra tokens. So that's just a little pointer for you. Always move that temperature to 0 unless you're trying to create a screenplay or something. So that's my talk. I have 2 minutes left. Does anyone have questions? You could. Yeah.
So can the hooks be used so we have a situation where we want to do we have a situation where we want to have a particular user accept 10 NFTs in one transaction. Can hooks be used for doing that?
Sure. Hooks can definitely accept a buy offer. I would have to clarify with you, though, that Zahao does not use NF tokens. We use URI tokens. If those URI token sales were there, you could essentially accept the buy offer. We'd have to discuss how exactly you're going to structure that. But yes, hooks trigger on any type of transaction. And then as we saw, we created our own transaction called invoke. And so you can always invoke a hook to do whatever you want based on parameters.
But we can't run it on the main?
Not on the main net, no. Anyone else?
I'm a .NET developer, not very common in this space.
Sure.
But, there is a WebAssembly compiler for .NET. Are you guys looking into enable? No, not Blazor. There's a standalone SDK.
We have a hook script, which is written in TypeScript. I've been discussing over the last couple days trying to get one in Python, realizing that C and Python is sort of very similar, so there may be some good libraries there that we can use, but I don't think .NET is on the horizon for us.
Okay.
Anyone else?
Hi, so this is quite an abstract question. So you started with a powerful statement about EVM are the capabilities that with hooks you can do anything that the EVM can do. I'd like for you to just give a quick summary of what hooks can do, what the EVM can't already do.
Well, it would be specific to XRPL and based on the transactions that are in XRPL. I don't think hooks could do anything more than EVM can do. I would say that a lot of people, new people, especially like me, end up incorrectly writing hooks or writing Solidity contracts. And so I guess just the biggest thing I would say is it's a fundamental change in the way you think about transactions. We hook on a transaction rather than in Solidity, you construct it and then you send the information in. This is much more like waiting for something to happen, but we do have that invoke transaction, which I was able to invoke all sorts of things to accomplish that task. I don't think I can actually say that hooks can do anything. Well, hooks can do a whole bunch of different things than EVM can do because it's on XRPLD, but I don't think I can answer that.
Can I add one
Yeah.
thing? I think one big difference between the EVM approach big difference between the EVM approach and the hook approach is that with EVM, the contract is basically the account. You send the entire thing in, it can do something, and it can. And with hooks, you install, you refer to little building blocks who are then referenced from your account. So you can build this list of little components that influence the transactions before they go through consensus and after they went through consensus. So it's a different approach. Basically, it's Legos. It's logic Legos on your existing account.
Any more questions? All right. Well,
Thank you.
Thank you, Dennis.